Welcome to the class, student. We'll continue organic chemistry. The next chapter is the alkynes. You have done already alkanes and alkenes. Alkynes are another kind of unsaturated hydrocarbons, and you know that the general formula is CnH2n minus 2. And the example which is there in your syllabus, that is ethyne, also called acetylene, having formula this structure formula, and the molecular formula is C2H2. So the structure of this you have to do in detail. That you will be doing in the chapter hybridization. They have a sp hybridization carbon, and that Divedi sir will teach you. So I'll start from preparation. So first method of preparation is by natural gas. So natural gas cannot be stored in the lab. So therefore this process is a industrial process. It is a manufacturing process. And natural gas chiefly consists of methane. So you can see this is the method of preparation of acetylene or ethyne, which is a gas from methane. So different methods are there, and the different condition we obtain acetylene. We have 4 reactions. First is methane, axis of methane. You can see 2 molecules of methane that is combining with nascent oxygen. Nascent oxygen means oxidizing agent, not from air, but oxidizing agent. And reaction is followed and we get ethyne, which is acetylene, and water is eliminated. Next is that we take axis of methane and oxygen, that is from air, and you have to keep temperature very high, 1500 degrees Celsius. It means methane burns in oxygen and gives acetylene gas along with these. So it is burning with the blue flame. All these 3 are combustible gases, and they burn with a blue color flame. The next reaction, third reaction, is in steps. That is methane. It is decomposing in this. Actually, you can say that methane, when heated strongly at very high temperature, then it turns into acetylene. So in different conditions, this acetylene which is formed here. This acetylene is formed from methane when we heat it, and reaction does not stop at acetylene, but when we continue heating, acetylene gets decomposed into carbon, black color powder, and hydrogen gas. So acetylene, you can see, which is formed here it is getting decomposed. So I have written down there, this acetylene which is forming, it is forming as an intermediate. It's not the final product in this reaction, but as intermediate. Therefore, it can be separated, it can be isolated, means separated. So, reaction is stopped here and is under the conditions are controlled, and so reaction is not further reaching to the end, and so we can get acetylene. So, it's a manufacturing process, industrial process. Then one more this thing method is there. Methane when heated with electric arc, not artificial heating, I means not by combustion, but when electric arc is passed, methane is passed on electric arc, then we get this. So all these 4 sets of reaction you have to do to get acetylene from methane. So here you see first 2 reactions when methane and oxygen combine, and the third and fourth reaction when there is no oxygen, direct methane is heated. Second reaction, that is from calcium carbide. This is most important method for examination point of view, and this is obtained from calcium carbide, and this is also industrial process manufacture. So first, that is calcium carbonate marble powder, that is heated, and we get calcium oxide and carbon monoxide. And then this calcium oxide which is obtained, this is passed over graphite rod. That's why it's written here electric arc. So temperature is maintained so much. Then calcium oxide, when combines with carbon, calcium carbide is formed. This is calcium carbide which is formed, and this calcium carbide is treated with water, and then we obtain acetylene gas. So reaction you have to learn, and we will see now the third method. This is first manufactural method. This is second manufactural method. Now the third method of preparation we'll see. Now the third method, by double dehydrogenation. Double dehydrogenation means 2 times removal. D is removal of hydrogen and halogen from 1 to dihalide. Dihalide means 2 halogens. So this is a compound which has 2 halogens. So first this hydrogen and this halogen will be out. Then once more, then when these 2 will be out, a double bond will be generated. Once more it will be, then this hydrogen and this X will be out in a triple bond. So this reaction will take place in 2 steps. First step is very fast, but the second step is slow. And this compound in which halogens are at different carbons, not on, it is dihalide written. So halogens are not on the same carbon but are on different carbon. That's why it is called vinyl dihalide or vicinal dihalide or simply vis dihalide. If halogen would have been on the same carbon, it would have been geminal, and geminals are not so stable and not used. And here, so remember that it is vinyl when halogens are, or it is dihalide, 2 halogens, but are not on the same carbon, are on the different carbon atoms. Now the fourth method, the last method, by Kolbe's method. Kolbe method is also called Kolbe's synthesis. Kolbe's synthesis, and this you have studied this method in alkane preparation and alkane preparation also. And so you know this is an electrolytic process. Electrolytic process. Kolbe's. In this case we will use, if you remember, in Kolbe's method we always use sodium or potassium salt of corresponding carboxylic acid. So here carboxylic acid is either maleic acid or fumaric acid. Malate and fumarate are the salt of malic acid or the fumaric acid. And malic acid and fumaric acids are not new term for you. This I have already covered in the chapter geometrical isomerism. Malate and fumarate. Malic acid and fumaric acid are geometrical isomers. So any one of the 2 is taken, the potassium salt of these are carboxylic acid, and the solution of this when through this current is passed, then this potassium ion is separated, it is getting ionized, and then we get, this is your either malate ion or a fumarate ion. Malate ion will be negatively charged, so it will be attracted to anode, and so reaction at anode is important. This is being positively charged, will be attracted at cathode, and our aim is not the electrolysis. Our aim is to prepare acetylene, so only this part is As you can see, is having carbon, so will be giving you acetylene. So only since it is negatively charged, so only reaction at anode is important. So here this malate or fumarate ion, when it gets attracted at anode, there it loses 2 electrons and then is turned into neutral malate or the fumarate molecule. And as you studied earlier, carbon with 2 free oxygen, this is a neutrality showing. Carbon with 2 free oxygen are not stable. So carbon dioxide will be automatically released. So 2 moles of carbon dioxide will be out. And when this is out, so we will have CH double bond CH. So balance the valency, one more bond will be established between the 2 adjacent carbon. And hence acetylene will be formed. Now we'll come to the physical properties. First is physical state. Carbon 1 to carbon 3. One is not so popular, that is your methane. So you can take it from carbon 2. So carbon 2, that is acetylene. So up till carbon 3 they are gases. Carbon 4 to carbon 11 are liquids. And carbon 12 and above they exist in solid state. Melting point and boiling point, these many points you have to do. 1, 2, 3, 4. First is slightly higher than those of corresponding alkane and alkenes. So you can compare with ethane and ethyne. So the ethyne will have slightly higher your melting and boiling point than ethane and ethene, because of the 2 reasons, and those reasons are your greater polarity and linear structure. Linear structure, that is this straight, that is linear structure. Whereas if I talk about 2 carbon, your ethane, it is not having a linear structure, it is having tetrahedral structure. So 1, 2, 3 and this is a 4. So it's not a linear structure for ethane, and this is for ethene, not linear structures, but it has linear. So because of the greater polarity and linear structure. Next is melting point and boiling point increase regularly. It increases regularly with increase in the molecular mass. So ethyne and then propyne and butyne, that way if you move down higher in the chain, higher homologous, then you will find that the melting point and boiling point is increasing. Then the branch chain alkynes possess lower melting point. So that is clear, you know that a branch chain isomer you have studied. Number of carbon atoms are same, hydrogen is same. But one is a straight chain, other is having branch. And if more branches are there but the molecular formula is same, that's what it means here. Branching alkyne possess lower melting point. More will be the branching, and that is lower will be the melting point. So here it is. Then boiling point decreases with the increase in the branching. So boiling point is just opposite of this point. Branching will increase. What will happen? That is melting point will decrease. Same, it is not different. It is same. Melting point will lower with the branching, and boiling point will also lower with the branching. So both are the same. And then density. Density, that is they have low density and are lighter than water and air. So we come to the chemical properties, and that is more important. We will start now. As acetylene is having triple bond unsaturated, so it will undergo addition reaction. Only few reactions you have to do. First is addition of halogen, Acetylene combines with bromine. You know bromine exists in the form of liquid. So liquid bromine that is having brown color, reddish brown color. And when it is passed over that, so triple bond will be turned into double bond. One Br will be attached here, one Br will be attached here. And further it combines with more of bromine. And double bond will turn into single and one bromine more will be added. So it will be tetrabromoethane. Will be formed. Nomenclature part we have already done. So that is tetrabromoethane will be formed. But the important thing is this, that this is a test for acetylene. It is not only a test for acetylene, it is also a test for ethene. And that's why I have written this is called unsaturation test. What is unsaturation test? When any unsaturated compound like alkyne or alkene is brought in contact of liquid bromine, which is having reddish brown color, then you will see it becomes colorless. So reddish brown color of bromine is discharged by any unsaturated hydrocarbon. So acetylene decolorizes bromine. And then when chlorine is passed in the presence of sunlight, then explosion is there, reaction is explosive, so it explodes. Acetylene explodes in chlorine in the presence of sunlight. And reaction is simple, triple bond will be turned into double. One chlorine on this, one chlorine on this, further reaction will be carried on. You have studied free radical reaction and free radical substitution and free radical addition, both reactions you have studied. And so here in the beginning you need sunlight, but later on you don't need any sunlight. And double bond will be turned into single bond. And one chlorine will be added more. So it is tetrachloroethane. Next is addition of hydrogen. Hydrogen when added, hydrogen gas is passed or from the any reducing agent, hydrogen is obtained. Then this is the catalyst. If palladium is used, palladium is also called Lindlar's catalyst, name you should know. Any one of the three used, temperature is maintained so much, and nascent hydrogen obtained from a reducing agent is passed, then triple bond, one hydrogen will be added here, one here, so triple bond will be turned into double. Once more, the same do means the same thing is repeated. Again two nascent hydrogen, that under the same condition will be added further, and ethene will be turned into ethane. So here it is, the same reaction can be done with hydrogen gas without reducing agent, direct hydrogen gas, but you will have to take palladium over barium sulfate, and then we get the end product as a ethene, not ethane. So remember the end product. Then of hydrogen halide, HX, hydrohalic acid also you can say, but the gas actually is used, so hydrogen halide. And acetylene when brought in contact of this, one H will be added here and halogen here, triple bond will be turned into double. This is not IUPAC name, IUPAC name will be chloro, it is X not chloro, so haloethene. And further it combines, then double bond will be turned into single bond and we will have haloethane. Now reaction with water, that is addition of water, that is more important. So I give you now the fourth example of addition reaction, addition of water. So this I will do for you, addition of water in acetylene. So when acetylene comes in contact of water or hydrolyzed, reaction takes place in two steps. First, triple bond will be turned into double bond. We'll have SC double bond CH, and this one piece will be attached there, the other piece of water will be attached there. Once more the reaction will be carried on because still we have a double bond, and so it will combine once more with another molecule of water, and This double bond now will turn into a single bond. One H will be added here, OH will be added from here. So this compound is formed, and I mentioned you earlier that on one carbon two hydroxyl groups are not stable. So this compound is unstable, and in organic chemistry unstable compound is shown in a square bracket, and so it automatically itself of its own releases one molecule of water. One OH from here, one H from here will release a mole of water, one molecule of water, and we will have this is left over, and here carbon and hydrogen, and this H is gone, this O is there. So to balance the valency, this is here. This compound is ethanol, 1,2-ethanol. This is ethanol. IUPAC name is ethanol, and common name is acetaldehyde. So we obtain acetaldehyde. Now if this happens to be R, any other higher alkyne you take, then this will also be R. R means any alkyl group, methyl, ethyl, any. So this H will also be R, and this will also be R. Okay. And if this H is also R, and then this H will also be R, then this H will also be R, and this H will also be R. Then the compound is not aldehyde, the compound will be ketone. The compound will be ketone. So remember that if hydrogen is present either here or there, we will get aldehyde. When no hydrogen is there with the triply bonded carbon, only alkyl groups are attached, we will get a ketone. So remember that, and now we'll do the substitution reaction, that is acidic character. Acidic character means any substance that can release hydrogen, that is your showing acidic behavior. So acetylene can also remove these hydrogen. One hydrogen can be easily released, both hydrogen cannot be so easily released. One can be released first, hydrogen can be released very easily. So these hydrogens which are present in acetylene are called acetylenic hydrogen. So these hydrogen cannot be replaced by your any substance or any metal, but only by very strong, very reactive active metals like sodium or potassium. So when sodium combines with this, both of this hydrogen is substituted, and when hydrogen is out, sodium will be linked over here and hydrogen gas. So to balance that, it is shown that here hydrogen gas is released and hydrogen is substituted by sodium, and the compound which is formed, that is called sodium acetylide. Very important reaction. So hydrogen can be replaced from acetylene only by sodium, and a salt is formed, that is sodium acetylide. Reaction can go further. This hydrogen can also be out, and disodium acetylide we can obtain, but this reaction is not obtained that easily as easily this one is obtained. Higher alkynes can also be they are made to react with sodium amide, and then in that case the alkyl group which is present here, the whole of this alkyl group can be substituted, and the sodium, this R is substituted by sodium, and we get sodium salt of acetylene which is called alkylide. Okay, sodium alkylide, because here alkyl group is there, we don't know what is the name for this. Would have been CH3, then propylide, and ammonia gas is formed. This reaction is more important. Then the next is combustion reaction. Two sets of combustion reaction you have to study. One is when it is burned in air, and the second is when it is treated with oxidizing agent. So when it burns with air, that is oxygen of the air, Then acetylene burns with a blue flame, and the product, combustion product, carbon dioxide and water vapor. So this reaction is more important when it reacts with camenophore. Under two conditions it reacts. One is cold and alkaline camenophore. When alkaline in cold camenophore is taken, means to the camenophore when an alkali is added, then nascent oxygen is released by camenophore, and this compound will be turned into a ketone. This is a ketone, diketone, that is formed. So second set of the reaction I will discuss with you. So reaction with camenophore, one condition you have seen, that is with cold and alkaline. Now second is with hot and alkaline camenophore. Alkaline camenophore is also called Byers reagent. You should know, sometimes it is asked what happens when acetylene is treated with Byers reagent, means treated with alkaline camenophore. So when Byers reagent is hot, we get initially this is a keto group and this is your carboxylic group, a mixed carboxylic acid. So if you take the IUPAC name, so 1, 2, 3, 4, so that but, single bond in butanoic acid, and this is your keto group, not getting a status of the functional group, so it is oxo. Prefix will be written oxo, and this is at carbon number 2, so this is 2-oxo. And when this is heated to 373 Kelvin, we get propanoic acid. Propanoic acid finally. Then second reaction is when acetylene is treated with hot and your alkaline camenophore. This was your higher alkyne, this is acetylene. When treated with this, we obtain oxalic acid. And when we take 4 carbon, your alkyne, and treated with hot and alkaline camenophore, we get acetic acid. So you should know this. What are the product obtained? Very higher your alkyne, we get propanoic acid, and when we take acetylene, we get oxalic acid, and when 4 carbon compound, we get acetic acid. The important thing about alkaline camenophore is whether cold or hot, whatever it is taken, the pink color of camenophore will be discharged when treated with an alkyne. This is another test for unsaturation that we have done in alkene also. So you can test that alkyne ethyne is having a triple bond by adding camenophore to this, either alkaline camenophore, either hot or cold, then its color will be disappeared. And so that will be confirmed for unsaturation. Now next reaction, that is ozonolysis and then polymerization. Ozonolysis. Ozonolysis you have done in case of ethene also. So ozonolysis, if I talk about acetylene is combining with ozone, you know ozone is splits into O2 and nascent oxygen, and O2 has a double bond. So addition will be there, HCCH, all here, 2 bond will be broken, 1 will remain there. In case of ethene where we were having 2 bonds, both bonds got broken, but here we have 3 bonds, so only 2 bonds will be broken, 1 will remain. Single oxygen will be commonly linked with both carbons, and these oxygen will be linked to each of the carbon atom. The compound is called ozonide, and this is hydrolyzed, you know, and the bond will split like this from 3 places. So here, since this is there, so we will have one this piece, this is here, one piece this and this oxygen. It is not splitting like as in ethene. So one oxygen is out with water and hydrogen peroxide will be formed, and this piece, if I write HC, this bond, then CH, then oxygen, And so here will generate a double bond. This compound is called glyoxyl. Common name is glyoxyl. Otherwise it is ethane dial 1,2. Okay. Now polymerization. Two kinds of polymers will be formed, linear or cyclic. Then linear, when acetylene is treated in the presence of Ziegler meta catalyst, then acetylene is turned into polyacetylene. You should learn the name, and that it is a linear polymer. And this is good conductor and is cheaper than metallic conductor. Cyclic polymer we can get from acetylene and benzene in the presence of copper tube or iron tube. If iron tube is taken, temperature is higher. If copper tube, then temperature is comparatively low. And we get a cyclic polymer, that is benzene. So here ends your alkyne. And the last thing, that comparison we have to do, and that I write for you. Distinguishing test between alkanes and alkynes. First three tests are important, and these two are most important. First is flame or combustion on burning. Alkanes are non-luminous and alkenes luminous, and alkynes is smoky. Non-luminous means with blue color. And then second is with the alkaline KMnO4. Alkanes have no action. Alkenes are decolorizing, pink color of KMnO4. Alkynes also decolorize, pink color of KMnO4. Bromine water or bromine in CCl4, carbon tetrachloride. Then alkanes have no action. Alkenes and alkynes will decolorize, that is brown color of bromine. With ammonical cuprous chloride, this is cuprous chloride. Alkanes have no action, but alkynes will show red color precipitate of copper carbide. Then with silver nitrate, these two will have no action, but alkyne will turn white PPT, will form white PPT to silver nitrate due to silver carbide. So that's all about alkyne. So here ends your aliphatic hydrocarbon, and my next chapter will be aromatic hydrocarbon. So till then, bye.